Hi, my name is Alexander. This is the first video related to the communication between Angular component and RESTful API with .NET Core version 8.0. In this video, we will create the server-side code RESTful API with .NET Core, which in turn will communicate with SQL Server using Entity Framework. In the next video, we will create Angular application, which will use RESTful API service CRUD methods to create, read, update, and delete the records in the customers table of the store database. In the local SQL Server, I have created already a simple database with the name store containing table customers. The table contains the following columns: customer ID, which is a primary key in this table, customer name, created date, customer type ID, state code, which represents the abbreviations of the US state names. Let's start create RESTful API service in Visual Studio 2022 with .NET Core version 8.0. Let's start a new project. Select project template ASP.NET Core Web API. Next, name of project, project directory. Next, keep default options, create. To communicate with the database, I will use Entity Framework. To use Entity Framework, we have to install a couple of packages. Let's start. Tools, NuGet Package Manager, Manage NuGet Packages for solution. Browse. Microsoft Entity Framework Core SQL Server to communicate with SQL Server. Microsoft Entity Framework Core Tools. It is tools for NuGet Package Manager console in Visual Studio. In particular, we will use command scaffold-dbcontext to produce an Entity Framework model from the existing database and dbcontext. Also, I will install newtonsoft.json to serialize the object via client-server connection. The concept of serialization and deserialization is used whenever data pertaining to objects have to be sent from one application to another, like from server to client. We can see all installed packages under Solution Dependencies Packages. Now, using scaffold-dbcontext command, we will create model class and dbcontext class automatically. Let's go to NuGet Package Manager console. Here we will execute the command scaffold-dbcontext. Here, server Alexander is the name of MySQL server. Database name is store. Trusted connection true specifies Windows authentication. And I have to put your attention that we have to include another parameter, trust server certificate equal true, to avoid an error which is called the certificate chain was issued by an authority that is not trusted. Without this parameter, we will unable to finish this command successfully. So this parameter is important. We indicated the package Microsoft Entity Framework Core SQL Server and output directory models, where the model and dbcontext classes will be automatically generated. Press Enter. This command automatically creates entity classes for each table in the database and the context class under specified folder. We specified folder name as models. In our case, we have only one table in the database, therefore command created only one model class customer and dbcontext class storeContext.cs. Open storeContext.cs. Created context class explicitly uses connection string with warning about it. Instead, we can put a connection string under appsettings.json file. And now we can indicate just connection string name in the store context class and remove warning from the code and unnecessary using statements. Now we have to register store context class in a program.cs file. Open program.cs file and add this line. Now we also will use scaffolding to automatically create controller that supports CRUD operations: create, read, update, delete. To create a controller, right-click on Controllers folder and select add new scaffolded item. Select Common API and API controller with actions using Entity Framework. Select our model class Customer and DBContext class Store Context. Press Add button. It creates customer controller class with asynchronous HTTP GET, PUT, POST, and DELETE methods. We can remove default controller whether for cast_controller.cs. Start application to check that it works. Yes, it works, and we can get the list of customers. Here's a list of customers. Because the methods should provide output to the client, which will be Angular application, I have to change the controller's methods. The new methods will return object of the type JSON result, which can be parsed on the client side. Let's change the code in customercontroller.cs. Add code private string serialized object. It is because new methods getCustomerList and getCustomer will return the data in a serialized object. Remove this code and remove all the code below the customer controller constructor. Add my code for service methods. I have implemented the following methods. GetCustomerList returns the list of customers as a serialized object. GetCustomer returns one customer as a serialized object. PostCustomer inserts a new customer in a database. UpdateCustomer updates selected customer in a database. DeleteCustomer delete customer from the database. I edit route attribute getCustomerList for the getCustomerList method to distinguish it from the second get method getCustomer. These two methods return data from the database. If the requested data was not found in the database, the anonymous object will be returned to client with the error message property. The value of this property will be displayed in the Angular client form field query status. Other methods PostCustomer, UpdateCustomer, DeleteCustomer will return the message to the client with the request status or request error when exception happens. The message will be displayed in the Angular client form field query status. In the case of exception, if an exception object has inException field, inException message is returned because inException provides more details about the exception. Otherwise, exception message is returned. Let's speak about parameters for the methods. Customer ID parameter for the methods getCustomer and DeleteCustomer will be transferred from Angular client application through the HTTP param object. And the customer object for the methods PostCustomer and UpdateCustomer will be stringified in Angular client application and will be sent to the server side through the HTTP headers objects. On the server side for the methods getCustomer and DeleteCustomer, customer ID is extracted from HTTP request query string. For the methods UpdateCustomer and PostCustomer, stringified customer object is parsed onto the JToken object, which contains all fields and values of the customer. In UpdateCustomer method, required customer is selected from the database and the value are updated using the field's value of JToken object in the private method setCustomer. In the PostCustomer method, a new customer is created and the values are updated using the field's values of JToken object in the private method setCustomer. The new customer object is added to the database through the DBContext object of Entity Framework. Because the parameters from the client side to the server side will be transferred using the HTTP param object or using stringified customer object under HTTP headers, for now we will test only getCustomerList method, which doesn't require parameters. Other methods we will test from Angular client in the next video. Start application. Test getCustomerList method. It works, and in an output we have a list of customers as stringified object. But if we will try to send a request to Web API from the client URL, the request will be blocked by the course policy. Cross-origin resource sharing is HTTP header-based mechanism that allows a server to indicate any origins, domain, scheme, or port other than its own from which a browser should permit loading resources. In our case, API origin is localhost port 7183 API customers customer list. But when we will send a request from Angular client application, the request's origin will be localhost port 4200. To resolve the course issue, we need to tell the browser that we allow the request from other URL or URLs. To implement this, we have to add the following line in the code of programs.cs file. Here we allow the request from URL HTTP localhost port 4200. We can even specify the asterisk symbol as a parameter for the withOrigins method. But it is not a good idea, because in this case the requests will be allowed from any origin, which is not good for the security reasons. To confirm that the application works, start application again and test getCustomerList method. In the output, we have a list of customers as a stringified object. That's it what I wanted to show you in this video. The link for the next video, where we will create Angular client application, is indicated in the description of this video. Thank you for watching, please subscribe to my channel, and have a good day.